Hi everybody, Patrick here from engineeringshot.com, paintballprops.com, and electroniclessons.com. We've got a Kickstarter campaign up right now for a large 4-digit 7-segment display, Arduino compatible. It has a up counter, down counter, and down count timer mode, and it's again Arduino compatible. We're going to put one together from scratch. First, we're going to talk about the components. These are the large 5-inch common nano displays. We'll wire that together later. Let's have a look at the components. This set comes with 7 1 k ohm resistors, 6 10 k ohm resistors, 2 470 ohm resistors, 7 1.1 k ohm resistors, 78055 regulator, voltage booster, 7 NPN transistors, a 2-pin terminal block, a power jack, 2 0.1 microfarad ceramic capacitors, 2 100 microfarad electrolytic capacitors, a red button, a green button, a single 6-pin header, 3 4-pin headers, an 18-pin dip socket, 18-pin microcontroller, 3 LM324 quad op amp chips, 3 14-pin sockets, and 3 4-pin wire connectors. And also, depending on what you pledge towards in the Kickstarter, you might pledge towards an AC to DC wall adapter, and of course the aforementioned 7-segment displays. So first of all, let's populate all of the resistors. Alright, for now we're going to populate the 470 ohm resistors, the 10 k ohm resistors, and the 1 k ohm resistors. We'll place the 1.1 k ohm resistors later. I should mention that there are 8 10 k ohm resistors as opposed to 6. Sorry about that. Your 2 470 ohm resistors go in these 2 slots right here. They're labeled 470R. Your 10 k ohm resistors go in these slots right here. 10K, they're all labeled 10K. Here, 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 and here. They're all labeled 10K, and they've got their own resistor numbers beside them. Your 1 k ohm resistors go here, 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 and here. And they are all labeled 1K. Ignore R21. We are not going to populate anything here. So just R19, R17, R15, R13, R11, R9, and R7. Ignore R21 because that's going to control the dot on the 7-segment display, and we're not going to use the dot for this project. So solder those into place, and next we'll do our 1.1 k ohm resistors. They're a bit different. Notice these resistor slots right here. This is where we're going to place our 1.1 k ohm resistors. We're going to ignore this one again because it's associated with the dot output. So all the components here we're not using for this project. Now what you want to do is you want to bend your 1.1 k ohm resistors like so and place it into the slot. Now again, there's no polarity. Just make sure that you plant them flat down to the board. I'm going to solder them all into place, and you can see what it looks like when it's done. You'll notice that the transistors have a curved side, and the front has a flat side with writing on it. Now the transistor is laying on the flat side. When you look at the footprints for the transistors T1, T2, T3, T4, T5, T6, and T7, we're going to ignore T8. You'll notice that there is a flat side facing left of the footprint and a curved side facing right. So from a bird's eye view, you want to make absolutely sure that the flat side is facing left and that the curved side is facing right. Flat side, curved side. So I'll solder those into place. Again, we're ignoring T8. We're not going to be using it. I'll solder them into place and you can see what they look like. And just to give you a closer look at the resistors, that is how they are soldered into place. They're nice and neat. There you have it. Nice and neat. The 2 0.1 microfarad ceramic capacitors have equal sized leads. They are not polarized. They can be placed in the right slots in either orientation, excuse me. And the 2 100 microfarad electrolytic capacitors, they have a long lead and a short lead. Long lead is positive, short lead is negative. Very, very important. So let's have a look up close at the footprints for this, because we're going to need to make sure that we place these capacitors very carefully. We want to place our first ceramic capacitor in the C4 slot right here, and our other one in the C2 slot right here. Again, orientation is not a problem. Now, for our 100 microfarad electrolytic capacitors, we're going to place them right here and right here. Now, if you look very closely, there is a little plus sign above the left lead for this electrolytic capacitor footprint. So long lead goes in the left hole, short lead goes in the right. If you reverse that, you're going to blow up your capacitor when you power it up, so be very careful. On this capacitor right here, you place the long lead in the bottom hole, there's a little plus sign there, and your short lead in the top hole. Again, if you reverse that when you power up, it's going to blow up the capacitor and potentially harm the traces on the PCB. So that's very, very important. Solder those into place, and next we will solder in our headers. Your 6-pin header is soldered right here, and that is where we connect to Arduino if we so choose to. We don't need to, but we can. Our first 4-pin header is soldered in right here, and our last 2 4-pin headers are soldered side by side right here. Obviously, you want the long leads facing up. So solder those into place, and next we will place our sockets. The sockets are very easy. The 3 14-pin sockets are soldered here, here, and here. The single 18-pin socket is soldered here. Now, if you look up close, you'll notice notches on one side, on the footprint. There's a notch here on the left, a notch here on the left, and 2 notches on the bottom. Each of the sockets has a notch on one side. Make sure that from a bird's eye view, you line up the notches on the sockets to the notches on the footprints. If you don't, you might, when you place the chips in, you might place them in backwards, and that's not good for anybody. So solder those into place, and then we will solder in our power jack, our 7805, and our terminal block. The 7805 5-volt regulator, power jack, and terminal block are all pretty straightforward. They're easy to solder, easy to place. The power jack only fits in one way with the jack facing out. The terminal block has 2 sides, the terminal side and a plastic side. Solder it with the terminal side facing the outside of the board. If you reverse that, you're not going to be able to use it, obviously. And lastly, the 7805. It has the front has writing on it. It's black. The back is a silvery gray. The footprint right here has a little white stripe on the back. So you want to make sure that the whitish gray stripe is facing the left side of the board, and that the front side, the side with the black on it, is facing the right. Like so. When you solder it into place, just make sure it goes down as far as you can. Make sure that there are no shorts when you solder it into place. So that's the board. Now we're going to talk about our buttons and our booster circuit. Okay. For the buttons, we're going to need 2 of these connectors. I'm just going to keep one on the screen right now. I'm going to remove one of the buttons from the equation. The buttons can be mounted using this plastic nut. But what I'm going to do is I'm going to place the nut back on. I'm going to bring it on about halfway. You'll notice that there are 4 leads on the bottom. 2 are for the LED, and 2 are for the switch. Now, I'm not sure if you're going to be able to see this or not, but the 2 leads that are closer together are the LED leads. And there is, if you look very carefully, on one side there is a plus sign, and on the other there is a minus sign. You're going to want to solder yellow to the plus sign and white to the minus side. And the red and black can be interchangeable. It doesn't matter which one you solder to. You can solder black here or black here, red here or red here. But those 2 have to be soldered to the pins that are further away from each other. So if you solder this together when you power up the board, if the LED doesn't light up, you've likely had a soldering error here. So again, minus to white, plus to yellow, and the 2 pins in the back, doesn't matter, has to be either red or black. Both of them have to be soldered there. So I'm going to solder that. What I like to do is I like to take my little gripper. Now you may or may not have one of these, and I just like to grip it, add a little bit of solder to it. I don't want to add too much heat to the pads because this is a plastic button and you can melt it, so just be very careful when you solder your buttons. So solder both the buttons, and next we're going to talk about the booster, and we're going to test the booster. This is the fun part. This is a very important step. We have to connect the voltage booster, which controls the brightness of the display, and we have to test it before we complete the circuit to power the rest of the board. Now, what you're going to notice on the board is this 4-pin header right here. The pins from the right to left are labeled in plus, in minus, B plus, and B minus. B is for boost. Boost plus, boost minus. So we're going to make two connections here. We're going to bring out our multimeter and we're going to test. We're going to calibrate the booster. Then we're going to complete the circuit. So what we're going to do is we're going to connect, we're going to solder the red wire from your connector, your red wire, to in plus, and your black wire to in minus. And then we're going to connect it to the board and we're going to test our booster. Now there's a lot going on with this step. I've got my 9 volt 1 amp adapter right here and I'm going to plug that in just a minute. But right now I've got the black wire connected to in minus of the booster, and I've got the red wire connected to in plus. I've left the yellow and orange wires not doing anything right now. And all I'm going to do is I'm going to connect the board, with the red wire facing right and the white wire facing left. I'm going to connect that to the header. So as soon as I power up the board, what's going to happen is I'm going to apply voltage to the booster. Now I can tune the output voltage using this variable resistor. And what you're going to need for that is a very thin flathead screwdriver. Now what we're going to do is we're going to, once we powered it up, we're going to place the red probe of our multimeter. We're set to DC voltage, by the way, DC voltage measurement. We're going to connect our red probe to out plus and our black probe to out minus. And once we calibrate to 18 volts, we're going to connect to the rest of the circuit. So let me just prepare for a second. So I've plugged in. Be careful when you're taking a measurement. You don't want to short anything. So I've got 9 volts on the input, 12 volts on the output. So I'm going to carefully tune the output to 18 volts, or just under 18 volts. You can change the brightness of the display using this booster circuit. That should be fine. I can go really high if I want to. You don't want to set it past 18 volts, 18 or 19 volts. You can bring it down if you'd like. You can bring it down less in brightness. Well, let's just leave it at 17.92 volts. We can change later if we want, but 17.92 volts is perfectly safe. So now that we've done this, now that we've calibrated it, you can put a little bit of glue on there if you'd like, or you can leave it, and once you calibrate it to your liking, the brightness of the display, you can add a little bit of glue just to keep that variable resistor in place. So now I'm going to remove power, and we're going to solder the remaining 2 wires to the other side of the booster. As you can see, out minus, we want to connect the white wire there after we've calibrated, and connect the yellow wire to out plus. And after this, we're going to run a quick voltage test to ensure that everything's properly powering up, and then we're going to start on our wiring up our display. Okay, now before you power up again, double check your connections. Double check everything that we've talked about so far, because you don't want to power this up, especially when the chips are populated, which we're going to do last. We're going to populate the buttons and on this header right here a little bit later after we solder together the display, but you're going to want to make sure that everything's hooked up properly. You don't want this booster connected improperly. Anyhow, I've double checked it. I'm going to plug in 9 volts, and what I'm going to do is we're still checking DC voltage. I've got the multimeter off the camera right now, but just so you can see. And what I'm going to do is I'm going to go and look at the big chip, the big 18-pin chip. And what I'm going to do is I'm going to place my black probe on pin 5, right at the bottom, middle, and complete opposite on the other side of the board. That is the regulated 5-volt pin and ground pin. I should read 5 volts on my multimeter, give or take a few millivolts. So pin 5, and right across to the board of the other side with my red probe, I should read 5 volts. Everything's powered up properly, hunky-dory. We've got 18 volts going to the display, and we've got 5 volts controlling the digital circuitry. So now the fun part. Now is where we get into real DIY. Let's put together our display. Okay, so we've got our 4 displays out. First things first, we're going to talk about how we're going to wire this. Most rewards the Kickstarter are going to include a whole bunch of magnet wire. And magnet wire has an insulator that can be burned off or scraped off. And that's what we're going to use just to make it look a little bit more transparent. Now on my first version I used wire wrap wire. Wire wrap is actually a whole lot of fun. I love wire wrapping, but wire wrapping can get expensive, whereas the magnet wire is relatively inexpensive, and it's very reliable. In any case, here are the displays. What we're going to do is we're going to turn each one around from this perspective, leaving about half an inch between them. And now what we're going to do is we're going to make our basic connections. Now each of these, this is 7-segment display. 1, 2, 3, 4, 5, 6, 7, and then there's the dot. But we're not going to use the dot. We're going to use the 7 segments. So we're going to daisy chain connections from left to right here, so that all of the A segments are wired together. The B segments, the C, D, E, F, and G segments, they're all wired together. And then what we're going to do is we're going to wire them to the board, and then we're going to wire the power for each segment to the relative power segments on the board. Now it's this is where care really prevails. Take your time, and I'm going to show you now how to strip some insulation off the how to easily strip off some insulation on the magnet wire. So this is magnet wire. It just looks like copper wire, but it's not. It's got a thin layer of insulation on it. And what we're going to have to do is, because we're going to be using long strands of this to daisy chain the connections across, is we're going to have to use a knife just to scrape off some of that insulation. Now you can burn the insulation off with your soldering iron, but because the segments are plastic, you don't want to add too much heat for too long on there. So what we're going to do is we're going to use some needle nose pliers, and we're going to use our knife. I'm going to make the first connection on the end. What I'm going to do is I'm going to take the flat end, not the sharp end, of the knife, and I'm just going to scrape back. And you'll actually see it becomes silver because I'm scraping off some of the insulation. Now you don't have to scrape all the way around. As soon as you've scraped that off, you just have to wrap that around the segment pin, and then add solder, and we'll be testing continuity as we go along to ensure that the connection is properly made. But if you like, what you can do is you can turn the magnet wire around and get the other side too, but it's not necessary. So let's make our first connection. As you can see, I've already got a head start using the magnet wire, and I'm going to go through how to make your connections in just a minute. But first of all, I want to show you the pinout. Notice this area right here. When you turn the displays around, there's a little area right here, and that's going to be your reference point. So because we've got the unit turned around, we have to count our pins in a weird direction. This is pin 1, pin 2, pin 3, pin 4, pin 5, pin 6, pin 7, pin 8, pin 9, pin 10. So it's going clockwise when you're counting out your pins. Now the goal is to connect certain segments from each display together. Let me show you a better look at this. Each segment is given a letter: A, B, C, D, E, F, and G. So what we have to do with the magnet wire is we have to connect all of the A's together. And A is pin 7, so that's 1, 2, 3, 4, 5, 6, 7. So if you follow this wire that I've already wrapped right here using the magnet wire, it's connected to pin 7 on this display, and again over here to pin 7 on this display, and again over here to pin 7 on this display. Now I'm going to show you how to wire that, and again, just 1 second, but that's A. And so at the end on the right here, I've got an extra piece of wire that we're going to use to connect to the main board. You should label them. I will label them for reference, but that's A. A is pin 7 from this perspective. 1, 2, 3, 4, 5, 6, 7. B is pin 6. So 1, 2, 3, 4, 5, 6. And I've got this pin 6 connected to this pin 6, connected to this pin 6, connected to this pin 6 with an extra piece of wire to connect to the board. So C is pin 4. 1, 2, 3, 4. So you want to connect this pin to this pin, to this pin, to this pin, and you'll notice I've placed a lot of slack here, and that's just to make things easier. And as well, I don't know, you might want to have your displays further apart, but even if you want them side by side, once you're done wiring and everything's tested, you can use dollar store cable ties to tie everything together nicely. It makes it more transparent. So D is pin 3. 1, 2, 3. Here to here to here to here. Next is E, which is pin 2. So this one I haven't wrapped yet, as you can see. So I have to connect here, pin 2, here, here, and here. And I'm going to show you how to do that with the magnet wire. And then from there on, I'm going to show you how to test it with a multimeter. The magnet wire is going to be difficult for you to see, but hopefully you can follow along, because this is pretty easy. So what I'm going to do is first I'm going to prep the end of the wire, and again I'll be wiring from left to right. And I'm going to start with the cut piece. What I'm going to do is I'm going to take the top of my X-Acto knife, I'm going to shave off the coating. I'm going to take my trusty needle nose pliers. You can do this with your fingers too, you don't have to do it like this, but I'm going to take it by the end and I'm going to wrap it. Now you don't want to apply too much heat for too long, because you don't want to burn the plastic. So my soldering iron is heated up. I'm going to tin my soldering iron and I'm going to apply some solder to it. Wait for it to dry, give it a second, and then just give it a tug, make sure it's not moving. So we're going to do a continuity test in a second to make sure that that's actually connected. So now what I'm going to do is I'm going to give myself some more magnet wire. I'm going to give myself an equal amount of slack. I'm going to use this as a reference. And I'm going to, so that's about as much slack as I want. I'm going to cut it right here. Or rather, I'm not going to cut it, sorry. I'm going to bring it out to my table. Use the top of my knife. Not going to cut it. Sorry. Not going to cut it. So now I've got that little piece of insulation removed. And I'm going to use my fingers this time just to show you that you can do it with your fingers. Just depends on how you want to do it. And only wrap around the area that's been stripped of the insulation. So that's done. Add some solder to the tip of your soldering iron. Give it a second. Oh yeah, that's on there nicely. So now I'm going to do the same thing again. Give myself some more magnet wire. And this actually doesn't, it goes faster than you think. This isn't very tedious, and it can be quite a bit of fun too. So I'm going to go through this. I'm going to skip ahead. I'm going to do the last one. I'm going to skip ahead so you don't have to watch it. That's good. Skipping ahead. So give it about 6 inches off the end. Take your wire cutters. Strip it. Now you can label that E if you'd like. So next we have to talk about F, which is pin 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So all of the pin 9s need to be connected together. Once you do that, we're gonna wire our last segment, and that is G, which is pin 10. This is pin 10 right here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So all of the pin 10s, wire them together, leaving yourself a whole bunch of slack on the right, and those will be all of our segments. And after that, we're going to make sure that we have all of the segments labeled properly, and from there we're going to wire out the power supply for each segment. So there's 4 more wires after that. From there we're going to solder to the main board and test. So my main multimeter ran out of batteries, and I don't have another one to replace at the moment, so I'm going to use my Craftsman multimeter, set it to continuity tester mode, so every time it detects a short it offers a weird sounding beep. So even this multimeter it's like not in the best shape, but it'll do the job. So what I'm going to do is I'm going to zoom out, and I'm going to test all my connections. So I'm going to test to make sure that pin 2 over here is connected to pin 2 over here. And if it's not, I have to find out where it's not connected. So it's connected. My multimeter's giving me some trouble. Okay, so pin 2 is connected. Let's try pin 3. It's connected. Let's try pin 4. Okay, it's connected. Pin 5 we're not using. Let's try pin 6. Okay, pin 7. Pin 8 we're not using. Pin 9. And pin 10. Okay, so all of these are connected. Now you don't want to touch the wires. You want to touch the tops of the tabs here, because obviously the wires are connected. So again, just touch the tops or directly at the bottom. My multimeter really is all good, but so I hope you get the point of that. We're trying to make sure that there are no opens. You want to make sure that everything is soldered properly to each display. So now we've got segments A, B, C, D, E, F, G connected. We're ignoring the dot segment. So now what we have to do is we have to wire the power supply to each segment. So there's one pin on every single unit. We're just going to use pin 1 as the power supply pin for each display. But before we do that, I'm going to label these so that it makes it easier for me when I solder to the main board. Okay, each wire's been labeled. I'll go through it just one more time just so that you can reference it. A is pin 7, B is pin 6, 1 to the left, C is 1, 2, 3, 4, D is 3, E is 2, F is 9, and G is 10. Now, this rightmost segment is segment 1, segment 2, segment 3, segment 4. What we're going to want to do, excuse me, is connect them to the pads on the top. Now you might not be able to see this, so I will guide them out. G, F, E, D, C, B, A, 4, 3, 2, 1. So we connect pin 1 from segment 1 to pad 1. Pin 1 of segment 2 to pin 2. Pin 1 of segment 3 to pad 3. Oh, jeez, I'm sorry, you can't see that. And let me just do that again, I'm sorry. Pin 1 of segment 1 to pad 1, or to pad 1. Pin 1 of segment 2 to pad 2. Pin 1 of segment 3 to pad 3. Pin 1 of segment 4 to pad 4. They're all labeled. It's all good. So I'm not going to bother labeling those. I'm going to solder them pin by pin. At this point, you have to decide where you want your main board. Now, if you want your main board somewhere right in the middle, you're mounted on a piece of wood in the back, then you can just solder you can splice the pins from the middle of the board as opposed to having them on the right. I'm going to solder them on the right of the on the right side of the display. So what I'm going to do is for each and every one of those pads, this is D, I'm going to scratch off about a couple millimeters of insulation at the end. I'm going to tin that with solder, and then I'm going to solder that to pad D, because this is the D wire. I'm going to do that for all of the segments, and then I'm going to again connect pin 1 here to 1, pin 1 here to 2, pin 1 here to 3, pin 1 here to 4. And then we're going to populate the chips, put the buttons in, and power it up. Alright, for those of you still with me, I'm sorry about this video being a little bit convoluted. I appreciate your patience. It's a difficult video to put together. In any case, this is the last step before test. We're going to take our 3 LM324s. Notice each of them have a notch on the left. Remember the notches on our 3 14-pin sockets? These two are facing down, so we want to take 2 of our LM324s, make sure the notch is facing towards the bottom of the board, gently massage it into place. Be careful not to bend any of the pins. Also make sure once you've inserted them that none of the pins are actually folding over to the side, because that is a common mistake. Our last LM317, or LM324 rather, has a notch on the, well, has a notch on the left. We want it to fit here with the notch facing to the left of the board. It's in place. As you can see, I've soldered all of the relative pads, wires to the relative pads, sorry. And lastly, our processor, which has a notch on the left, placed it here with the notch facing the left side of the board. And our buttons. Okay, our red button goes on the bottom, so we'll do a green button first. We want to have the red wire facing left. Same with the red button, which goes on the bottom rail. Red wire facing left. Now we're ready to power up. Before I do, I just want to show you, you can barely see the wires as well. Once you've mounted your display in whatever case you decide to make for yourself, or however you decide to put it together, you can simply cable tie it up to make it look nice and neat. But from this perspective, it doesn't even look like you can't even really see it. So let's look at it from the front. We'll power it up for the first time. Here's hoping. Now, at 18 volts that we've tuned our booster to, should be nice and perfect. Yes. Arduino on, Arduino off. Let's just choose Arduino off. Not that we're going to be doing any real demos in this video. Let's do countdown timer mode. Function 3. We'll program in. Sorry, wrong button. Let's program in 60 minutes. Sorry, that was embarrassing. I was pressing the wrong button. It's hard to tell from this perspective. And go! 60-minute timer. Now, despite that stuttering, poor excuse of a video, which I apologize for, I put a lot of work into it. I spent just 6 hours trying to put the video together before editing. I obviously haven't edited this as when I'm speaking, but it looks great. It really does. So now the rest is up to you. If you want, you can pledge towards a wood set, but I encourage you to go forth and make this your own. Well, there will be a video manual available that will discuss how it's Arduino compatible, how it's standalone, how to use each and every function, and again, at the end of this campaign, I'll release the schematic to pledges. But yeah, I mean, this is a lot of fun to build. It's a large timer that you can build yourself at home. You can incorporate into your projects. If you own an escape room, you can put it into an escape room. Entertainment center, you can do so much with this, and that's where the Arduino comes into play. I'm going to reset. And what I'll do is I'm just going to, just for the sake of showing you, let's just do Arduino off. Count. Let's do count down mode. Let's just do 100. And hopefully that looks good. And you have pulsed. You have sent a pulse to the pulse line 100 times. The game is over. So you can make this into a target practice set, a countdown timer. You can do so much with this. And I will get to that. This video's gone way too long. I'm sorry for that. Thanks for watching. Have a great day. If you have any questions about the video, drop me a line. Check out our Kickstarter. Take care and thanks again.